We are going to start off by reviewing unit notes 1, 2, and 3. So let's start by reviewing some of our forms of equations. So first, our slope-intercept form of equation is y is equal to mx plus b. Okay, so remember that your m represents your slope, and your b represents your y-intercept. So this is something that I strongly encourage you guys to have on your final review note sheet because it's easy to forget those things. So slope is usually rise over run. Now I'm going to take this down here and make it a little bigger. Here's our slope formula, which is another thing I suggest you have written down. So to get the slope, you have, oops, that should be y2 on the bottom. So you have y2 minus y1 over x2 minus x1. So what you'll get is sometimes you get a point, x1, y1, and x2, y2, and then you have to calculate out the slope, and you do that using that formula. Now remember that the y-intercept is the point where the line crosses the y-axis. If you're looking at a Cartesian coordinate, x is the horizontal one, and y is the up and down one. Again, these are easy things to forget on the final that you might want to consider jotting down on your final note sheet. Okay, so let's take a look at point-slope form of equation. Now I taught my students to look at this like a puzzle, and we set it up like this. So here is the opposite of my y-coordinate. Here is my slope, and here is the opposite of my x-coordinate. You may have also seen it like this: y minus y1 is equal to m times x minus x1. So x1, y1 is our point. I like to look at it like a puzzle because then I just think, okay, all I have to do is plug in the pieces. You can write down whichever version is more comfortable for you. Then for the standard form of an equation, it's ax plus by is equal to c. Now standard form equation is used a lot for word problems. That's where we use it the most. In order for us to graph anything, we have to convert things into slope-intercept or slope-intercept form because that's the easiest way to graph. So let's take a look. So we have 3 problems, and all of these ask us to put the following equations into slope-intercept form. So to do that, first of all, this one gives us our slope and our intercept. So we just really have to plug it into the formula y is equal to mx plus b. So m is my slope, that's negative 2/3 x, plus my y-intercept is negative 3. So I get negative 2/3 x plus a negative 3. And that's my slope-intercept form. For slope-intercept form, your y always needs to be isolated by itself. Taking a look at number 2, we have 2 points. So the first thing we need to do is calculate out the slope. So I have x1, y1, x2, y2. So I have y2 minus y1 over x2 minus x1. So I get negative 6 divided by negative 3. And when I divide those out, I get 2. A positive 2. So what I have right now is I have a slope and I have 2 points. Well, whenever I have a point and a slope, I need to start by putting it into point-slope form. So I need to set up my puzzle. So there's my puzzle right there. So in here goes my slope. So I put my slope there. Then I just need to pick a point. I'm going to pick the point 6, 2. You could pick the other one if you want to. Then I'm going to put the opposite of my x-coordinate in here and the opposite of my y-coordinate in there. Now we want to have this in slope-intercept form, so I need to solve for y. So I'm going to start by taking the 2 and distributing it in. So I have y minus 2 is equal to 2 times x, which is 2x, and 2 times negative 6, which is negative 12. Now I need to add 2 to both sides. So then once I've added 2 to both sides, if it'll let me here, I end up getting y is equal to 2x minus 10. I noticed that I didn't add the 2 to the x. I just added the 2 to the constant. So this right here is my slope-intercept form. Okay, taking a look at number 3. For number 3, I want to basically just solve for y. So that's how I can get things in slope-intercept form, is just solving for y. So I'm going to start by adding 2x to both sides. So I get 3y is equal to 2x plus 6. So then I'm going to go ahead and divide both sides by 3. So I get y is equal to, here that's going to become the fraction 2/3 and then x. And then 6 divided by 3 is 2. So that right there is your final answer for number 3. Let's take a look at number 4 and number 5. So this is from Unit 2, and in Unit 2 you worked on solving systems. So what I want to do is just review each of the methods that you learned for solving systems. The first method you learned was substitution. So you see how y is equal to this thing right here? That means that that can be substituted out for y. So where you see y down here, you can put 5x plus 1 in instead. So you get 2x, and then instead of writing y, I have 5x plus 1 is equal to 15. So now I need to write that out. 2x plus 5x is 7x plus 1 is equal to 15. So now I need to solve that for x. So I'm going to go ahead and subtract 1 from both sides. So I get 7x is equal to 14. Divide both sides by 7, and I get that x is equal to 2. So now what I need to do is I need to see if I want to extend the page. There we go. Okay, so y is equal to 2. So then what I need to do is I need to take that 2 and I'm going to plug it in for this x here. You can actually plug it in to whatever x you want, okay? But I think the top one's easier because it's already solved for y. So what I'm going to do is I'm going to take the x out completely, put 2 in instead, and then I have plus 1. So then I have 10 plus 1, so I get that y is equal to 11. So once I've done that, I get that x is equal to 2 and y is equal to 11. So I write it out as a coordinate point, first my x, then my y. So there's my solution. Taking a look at number 5. Now number 5 is one that we could easily use elimination if we want to. In order to use elimination, you need same coefficients, opposite signs. So I see that this y has a 1 with it. That makes it easy to use elimination. So what I'm asking myself is, what do I need to multiply 1y by to get a negative 5y, because I want it to be the opposite? Well, I need to multiply it by a negative 5. So I'm multiplying the top by a negative 5. So I have a negative 10x minus 5y is equal to negative 40. And then I have 3x plus 5y is equal to 26. So now we can go ahead and add down the columns. Negative 10x plus 3x is going to give me 7x. 5y plus negative 5y cancels out. Negative 40 minus or plus 26 is negative 14, and this should be a negative 7. So we're going to go ahead and divide both sides by negative 7, and again I get that x is equal to a positive 2 when you divide two negatives. So then we're going to take and we're going to plug in 2 there or there. It actually doesn't matter. You can decide. I'm just going to plug it into the top one. So I take x out of the top one and I put 2 in instead. And then I have plus y is equal to 8. So 4 plus y is equal to 8. Subtract 4 from both sides and I get that y is equal to 4. So now I want to write that out as a coordinate point. First my x, then my y. So that's my final answer for number 5. Let's take a look at our rules of exponents. So one of our first rules of exponent is product of powers. So that's just saying, so when you have a product of powers, you multiply your exponents. Okay? So for example, if you had a to the third, or sorry, not multiply your exponents, good gracious, Miss Humbert, add your exponents. So if you have a to the third times a to the fourth, you add your exponents and it's going to become a to the seventh. If you have a power of a power, here is where you're going to multiply your exponents. So if you have a to the third, and that a to the third is being raised to the fourth power, then you need to take 3 and multiply it times 4. And that gives you a to the 12th. If you have anything to the 0 exponent, it always equals 1. So even if I have 1,000 a to the third, and all of that is being raised to the 0 power, as long as the entire thing is being raised to the 0 power, it's always equal to 1. Now, if you have a quotient of powers, you're going to divide the coefficients, but you're going to subtract your exponents. So if I have a to the fourth divided by a to the third, I'm going to subtract those exponents, and 4 minus 3 is a to the first power. When you have negative exponents, if I have negative exponents, you need to flip where they are located. So you're going to flip where they're located. So if I have, for example, a to the first negative 1 divided by b to the negative 2, all I'm going to do is flip where each of them are located. And when I flip where each of them are located, their exponents do become positive. So let's take a look at practicing some of these. So first of all, for number 6, I have a bunch of negative exponents. So I'm just going to flip the b to the negative third. I'm not going to flip the 4 because that doesn't have a negative exponent. I'm going to take the a to the negative 2 and flip that to the top. So I have 4a squared up top, then I'm flipping the 4 down below, and then I get b to the third. Or not the 4 down below, I just said I wasn't doing that. I'm struggling today. And just the b third comes to the bottom. So this right here is your final answer for number 6. Now taking a look at number 7, what I suggest doing before you simplify anything out is simplifying the parenthesis itself. So I have 4x cubed y, and then I'm going to take that y to the second and raise it up top because it's negative on the bottom. And now I want to simplify within the parenthesis as well. So now 4 divided by 6, I can reduce that fraction to be 2 over 3. And then I have x cubed divided by x to the first. Subtract those exponents and I get x squared up top. Y to the first times y squared is going to give me y cubed. Now notice that that's being raised to the negative 2 power. So actually what I'm going to do is I'm going to flip the fraction inside like so. And then that's going to make that a positive 2. Now that exponent of positive 2 needs to be distributed into absolutely everything, including our numbers. So we're going to distribute it to here, 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 here. Now when I distribute it to the 3, it's not 3 times 2, it's 3 to the second power, divided by 2 to the second power. X to the 2 times 2, again you're multiplying those exponents, is x to the fourth. Y to the 5 times 2 is y to the 10th. Well, 3 squared is 9, divided by 4 squared, or 2 squared is 4, and then x to the fourth, y to the 10th. So this right here is your final answer. Oh, this is y to the third, isn't it? So this should be y to the 6th. I'm sorry. And that's your final answer for number 7. All right, let's take a look at number 8. So for number 8, we need to distribute in this negative sign. Whenever you see the second half being subtracted, I always suggest you change the signs of everything so you don't forget that you're subtracting. And now we're going to combine like terms. When we write things in standard form, we want our largest exponent to come first, which is negative 4n cubed. And that negative 4n cubed, I see that there's another 13n cubed that it can be added with. So 13n cubed minus 4n cubed is going to give me 9n cubed. And now I've taken care of the cube terms. And then I have plus 3n squared, that doesn't have anything to be added with. And then I have plus 5n minus 7n, so that's going to become minus 2n. So that right there is your standard form simplified version. To simplify out number 9, I usually use the box method. You can also use a method called FOIL as well. Pick what's easiest for you. So then 4 times 3 is going to give you 12 and then x squared. 4 times negative 2 is negative 8 and then x. 3 times 2 is 6 and then x. 2 times negative 2 is negative 4. So then I get 12x squared minus 8x plus 6x minus 4. So what you need to do is you need to combine like terms. And you can only combine things of like exponents. So we can't add x squared with x because they don't have the same exponents. And when you are adding like terms, you do not add the exponents. So when I take negative 8x plus 6x, that's simply going to become negative 2x and then minus 4. Again, with exponents going in descending order. So that's your final answer, and that concludes your note video. There is no Schoology quiz. This is simply to help you review. Thanks for listening.